Okay, here's a small project that we were doing with a group of 3 with 2 other people that I work with, which was quite nice. So in this project, we are looking at the entangled states, and first we are using Qtip, and first we are generating the Bell states, the symmetric entangled states, and measuring them with the probabilities. And as we know, they are like 0, 0, 50, 50%, 50%, 50%, 50%. After that, we are looking at the partially entangled states. We generate them by just mathematically creating, putting the coefficients and then multiplying by the state and adding them all up. With this, we can create different entanglement state, non-symmetric entanglement state with like 75% 0, 0 state, 15%, 25% 1, 1 state, and like that. We also looked into the Hamiltonians that can create these entanglements, but this way it was much nicer to simulate since it's easier to put the coefficients just like this. After that, we are looking at the entangled state with small random errors, and yeah, we're just generating with random errors. After this, now that we have a more we played with the entangled states and the Bell states. Now after that, we move on to creating our own entangled state with Heisenberg model X. And as you can, of course, not only creating them, but looking them under the time dependency with the me-solve function of the Qtip, which is using the using Heisenberg's equation to add the time dependency. And then as we can see, just because of the input state that we are giving 0, 1, we are seeing this graph just shows the 0, 0 state, 0, 1 state, 1, 0 state, and 1, 1 state. And then we can see the oscillation in the 0, 1 state. As the 0, 1 state goes down, the 1, 0 state goes up, and the oscillation moves on with the time. And the only reason that we are seeing the oscillation in these two is just because of the fact that our input state is in 0, 1. So if it were to be in 0, 0, we would see the oscillation in this and this state, this and this diagonals. I said diagonals because these are just the result matrices projections, where the first diagonal represents the 0, 0 state, and the second one represents the 0, 1 state, and goes on like that. So in the Heisenberg model XX, there's the J coefficient in the matrix, which we created the coefficient constant, something like that. And we can see by change, we can see the effects of J on the oscillations. And interestingly, this J number is not really realistic, since they are usually like 2 times 10 to the negative 24 or even smaller. But we couldn't really use that small numbers with the interact. So just to see, we are using between 0 and 500. And we see some quite interesting behavior. Of course, we keep seeing the oscillations, but the oscillations start other types of oscillations, as you can see under these circumstances. We don't really know why this happens, but we assume that's because of the fact that it's just such a big J, and the time frame that we are looking is so big, so that we don't really, it's moving so fast that we are seeing them in both of the positions, kind of like a little bit like. So yeah, we can manipulate them, and as you can see, the frequency changes, which was expected to see, and these kind of interesting behaviors can be observed. And at, of course, J equal to 0, we will see a nice oscillation. But yeah, whatever. Okay. So for the other part, we use Icing metrics. And with the Icing metrics, there's a phi constant in the Icing metrics, as you can see. We said angle, but this is not really the angle. This is also has a time dependency, the phi value, the angle basically. And as you can see, we are starting with the 0, 0 state, and as the angle changes, our entangled bits change too. yeah, so for example, at phi over 4 it goes to 50%. I can't really show, but probably at phi over 4 it is 50%. And at phi at pi over 2 it is 100%, which makes sense. And at probably pi it's just 0 state back where we started. And at 2 pi it's the same again. So yeah, we basically just played with the entangled states and saw the different aspects of it and created our own entangled states and looked them under the time dependency and changing the by using Heisenberg model XX and the Ising gates, the Ising metrics, sorry, and looked at them by changing the phi or the constant j in them, which was quite nice.